What I have here is a Rosemont 3051 differential pressure transmitter. And so it consists of a transmitter, a sensor, and a block and bleed three-way manifold. In the bottom are the high and low diaphragm, and the inside is the actual DP sensor. This is that same three-way manifold valve. So as you can see, it consists of two bleeder fittings, two isolation valves, and one equalization valve. These right here are the sensor ports, and if I flip it over, these right here are your threaded ports so that you can install your actual tubing. This is how the actual manifold is designed internally. So you have your bleeders, your ISOs, and your equalization. I'm going to use this DP transmitter to measure the level inside this tank. I went ahead and did the math. So this right here is the math for a wet leg configuration. So as you can see, I did my high side pressures, which are the measurements of the tank. And then my low side is the wet leg. So high side minus low side equals the difference in pressure, which on the wet legs, you're always going to see negative values. Here I am changing the ranges for the new configuration. So my lower range is going to be negative 39.75. And my upper range is going to be negative 9.75. Once I make these changes, I'm going to go ahead and send it and save it to the transmitter. Now that the transmitter is properly configured to the system, I'm going to go ahead and put the controller at 50% system stabilized before I put it on manual mode so I can test out the transmitter. A little time lapse of the PV matching the set point. Now that the system stabilized at the set point of 50%, I'm going to go ahead and transition from automatic to manual. So as you can see, there is no hiccups going on between the closed loop. So this is what you call a properly designed PNID. So now that the controller is in manual mode, I'm going to go ahead and play with the transmitter. So high sensor, low sensor. High sensor is process side, so I'm going to go ahead and isolate the high side isolation valve and open the low side bleeder. So once again, this system is just water, but if you're in the field, obviously follow your MSDSG for the proper PPE. Just a side note, anytime you're using these type of bleeder fittings, always make sure that weep hole is pointed down or away from you because some of these systems run under high pressure. Next, we install a stinger adapter. And so this fitting right here just allows me to connect my Roston pump. Make sure you give it a little snug. If you don't, it's going to end up leaking and your pump won't be as stable. So now that I have everything hooked up, at 0 inches of high side pressure, the transmitter will read negative 39.75 at 4 milliamps. 7.5 inches of high side pressure will equal negative 32.25 at 8 milliamps. 15 inches of high side pressure will equal negative 24.75 at 12 milliamps. 22.5 inches of high side pressure will equal negative 17.25 at 16 milliamps. Lastly, 30 inches of high side pressure will equal negative 9.75 at 20 milliamps. So now that the transmitter passed within 1%, go ahead and bleed the pump by actually disconnecting it. Don't use the bleeder on the actual pump itself because after a certain pressure, your pump becomes a vacuum and you'll suck up all that process that's stuck in the sensor and it'll just damage your pump. And so at this point, I'm just going in reverse on the block and bleed procedure. So now that the transmitter's back in service, I want to go ahead and put the loop in automatic. So as you can see, 15 inches is 50% set point. So if you look at the 789, the transmitter is producing around 12 milliamps within 1% error margin.